Did your mom turn in a permission slip? You did? Okay. Good morning. Fine. How are you? Sorry. Go away, Jaime. Yes, I think that would be a wise idea. Okay. Ladies and gents, my suggestion is too, when you're working on your journal entry, if I were you, I'd kind of go over your notes a little bit too. Okay? Justin.
I'm absent Tuesday, so I need to make what I need to make.
Okay, well then you need to go and get the notes from somebody in class. Okay? Because we had a minimum day that day, so we took notes and played around with 2 polymers, and I'm going to see whether or not you guys can remember that. You would have some, maybe? No, these are your notes, right?
Those are hers.
Oh, those are hers. Would you have some?
No,
That's what you with Mr. Stutton. Okay. And who did you borrow those from, Jana?
No.
2 things about polymers. You remember? Okay. Hey guys, about 30 seconds to finish your thoughts. Okay, ladies and gents, somebody in here raise your hand and tell me something that you've learned about polymers, something that you know about polymers based on last class period, something that you know about polymers. John?
Yeah, that man-made polymers are stronger than natural ones.
Could be. So you learned about man-made versus natural polymers. So they come in 2 kinds, man-made and natural. Somebody else. Clara.
Poly mean many.
Poly means many. And remember this sheet of paper here. You used this before when we were graphing to try to get as much information as you can about polymers, because what can you do with this sheet of paper that I'll let you do? So, yeah, you can use this for a test. Okay, Tegan.
They're gigantic molecules.
They're gigantic molecules. Okay. Daisy.
Mono means one.
Mono means 1. And what's so important about mono?
It takes 3 monos to make a polymer.
Well, it takes more than 3 monos to make a polymer because they're gigantic molecules. But give me kind of a definition of a monomer. You kind of gave it to me, but kind of rephrase that. In other words, Daisy, if I were to ask you what is a monomer, what would you tell me?
A chain? Wait.
Anybody? What is a monomer? Amber.
Are they simple molecules?
Yeah, they're simple molecules. So if we take the simple molecules, Daisy, and we put them all together inside of a chain, what have we created?
A polymer.
Bingo. Okay, so mono means what?
1.
1. Okay, good. Anybody else? Cynthia.
Polymers are molecules joined together.
Polymers are molecules joined together. And they're joined together. How are they joined together? I mean, if you had to describe what they looked like when they were joined together, what would you tell me? They're around one another and they're linked together. What are they linked together in, Savannah? Polymers can be linked together with a cross-linker, but if you were to take a whole bunch of monomers and link them together, what have you kind of created?
A chain.
Bingo. Thank you. A chain. Okay. So joined together, and they're kind of like in chains. Oh, they can be in chains, but with the ones that we talked about were in chains. Okay? Anything else you want to add to this? Okay, we can write mer. Let's try to kind of how to remember you to remember molecule. Okay? Savannah.
They can be all scrunched together.
Okay.
Up and down and side to side.
Okay, good. And this is what was really important, because we're going to take what Savannah has said and we're going to take this one step further today in class. Savannah mentioned that the polymers the chains can kind of be arranged 2 different ways. She said side to side, and we'll call that parallel today. And then how was the other one? Do you remember? Scrunched together, kind of like crisscrossed. Okay. Okay. And this, ladies and gents, is what we're going to focus on today. Okay, we're going to talk about parallel and cross-linked chains and what actually does that do to the polymer. You guys remember the polymer, the newspaper polymer? Do you guys remember that? You guys remember that? Somebody here tell me, how were the chains arranged in the newspaper? How were the chains arranged? Derek?
Like in order.
Were they more arranged parallel or were they arranged crisscross?
Parallel.
They were parallel, and because they were arranged parallel, what could you do to the newspaper?
Rip it easy.
You could rip it very, very easily. Okay, what was the other thing that we used in class? Does anybody remember? Amber?
Pepper.
Tevic. And how were the molecules arranged in the Tevic? They're crisscrossed. And what did the crisscross molecules do to the Tevic?
Made it hard to tear.
Made it very, very hard to tear. Okay? All right. So remembering that, parallel and crisscrossed, we're going to go ahead and we're going to take a look at this. And we're going to take a look at these arrangements of these chains and how that kind of helps us determine what is actually going to happen to the polymer. How is a polymer going to behave? Okay? All right. What I'd like for you to do right now is take out one clean sheet of notebook paper. And if you would do me a favor and put your notebook on the floor. So the only thing that should be on your desk is a piece of notebook paper. Okay. I'm going to go over here in the overhead, guys. I'm not going to turn the lights off because I'm not going to be up here for very long, okay? But what I want you to do on your piece of paper, which is going to kind of help us with the labs that we're going to do a little bit later on. We are going to look at polymer chains. So what I'd like for you to do is to write down polymer chains. And this is a little bit background information. Kind of a review from what we did last class period, but also to let you know where we're going with the lesson today. Okay. This is monomers. You guys remember that when we kind of drew this picture of nylon last class period? Okay. This is actually polystyrene, which is up here as a plastic container. And one of the really, really neat things is that if you look at the polymers and you look at all the names of the polymers, what's at the beginning of all the names of the chemical names of the polymers? P-O-L-Y, poly. And that gives you a really, really good idea that that must be a polymer because it has P-O-L-Y on it. And if we remember, we've got one carbon atom. We have two hydrogen atoms that are bonded together to another carbon and a hydrogen. That's your monomer. You take a whole bunch of monomers together, and what have you created? A polymer. Okay, good. Okay, this is what we're going to concentrate on in class today. The arrangement of chains can influence the behavior of the polymers. And it kind of goes back to our little bubble over there where we were talking about compounds are formed by combining two or more elements whose properties are different from their original elements. Here you have a whole bunch of elements, you put them together, and you've created something brand new. Okay, based on what we talked about last class period, we talked about the newspaper and we talked about the TEVIC. Would you please write down on your paper how the polymer chains were arranged in the newspaper and how they were arranged in the TEVIC? You may draw it, absolutely. And would you also please write down where Tevic, newspaper and Tevic, would you also please tell me how did that newspaper behave? In other words, because the polymer chains were arranged in such a way, how did the newspaper behave as far as tearing is concerned? Okay, questions so far? Questions? Okay, excellent. All right. We're going to go now into investigating polymers. And what I'd like for you to do on this same sheet of paper is investigating polymers activity part 1. And this is going to be a demo that I'm going to do. And then after the demo is over, I'm going to break you up into your lab groups. And then you guys are going to take a polymer and you're going to investigate a polymer on your own with your group. Okay. Alrighty. The first polymer, John, you want to share something?
No.
Okay. First polymer that I'm going to share with you is, I want you to write this down on your piece of paper. It's this one right up in here. It's called plumber's tape. I don't know if you guys can see it from here. And you can really, really impress your parents today when you go home. And you can ask for plumber's tape, because that's what it's just. If you go into Home Depot and you say, I need plumber's tape, well, they know exactly what you're talking about. But if you go into Home Depot and say, I need poly, tetra, fluoro, ethylene, they may not know what you're talking about. Here you've got the poly, which means the many. Does anybody here know what tetra means? Tetra means a number. Can you?
It means like, well, no, I thought I missed something else.
Anybody here know what tetra means? Okay, tetra is a number. Usually what happens up in here is that they'll actually tell you how many of those molecules are actually bonded together. Fluoro is probably fluorine off of the element table. And then ethylene is also another couple of different elements off of the periodic table. So you put all these together and you get them all in a nice big old polymer chain and you created plumber's tape. Has anybody here ever fooled around with plumber's tape before? Do you guys know what I'm talking about? This stuff? Not duct tape, plumber's tape. That's plumber's tape in here. John, share your experiences with plumber's tape.
Yeah, it's not sticky, but it's like, when you wrap it, it squeezes really tight around things. It's like Teflon tape. You can fix gas leaks with it. That's what I used it for. Okay, and that's what I use it for, to fix gas leaks, and also it's really, really good for water pipes and threading and things like that too. As a matter of fact, yeah, also known as Teflon, so you're correct in that assumption. Yes, Clara?
I wrapped it around my finger and it turned my finger all purple.
Well, yeah, I think so. If you wrap anything around your finger, it's going to turn your finger all purple. Anybody else? Okay. I don't have a lot of plumber's tape to go around, but what I'm going to do is that I'm going to pass some plumber's tape around to some volunteers in the audience. Does anybody want to take a look at the plumber's tape? And I kind of disperse it around. That way people around you can take a look at it too. The only thing that I'd like for you to do with the plumber's tape when you get it is just to kind of leave it on your desk. Don't do anything to it other than just leave it on your desk, nice and flat if you possibly can. Let's see, Jennifer. I'll give you some, Tony. Okay, can everybody, Savannah, I'm going to give you some so that you guys can take a look at that. What about over here on this side of the room? Okay, Justin, I'm going to get you a piece too. I think I have another piece up here. Okay. Yeah. Yes, you can. You can just leave it flat. Touch it, you can actually see how flimsy this is too. And actually they make another type. This is more for pipes. And there's another one that's a little bit more flimsier. That's what we used this morning for threading water pipes and stuff like that. Actually, it just does it by, you're going to figure that out. Okay, I'm not going to tell you. You're going to figure that one out. Okay. For those of you in here who have the plumber's tape, do me a favor. See whether or not your ink pen or the pencil, whatever that you're using on it right now, that you can write your initials on it. See if you can do that with the plumber's tape. If you guys want to feel it, who doesn't have any, you guys can actually see what that feels like. It's kind of really smooth. It kind of feels good. Huh? That's okay. Rip through? Okay, then maybe you don't want to go in too deep then. Then don't do that then if it's ripping through, because that's not a good thing. Oh, good. Cool. Okay, good. All right. Ladies and gents, we know this is a polymer because I told you that. The job is now to figure out how the polymer chains are arranged. We know that polymer chains can be arranged two different ways. They can be arranged parallel to one another, or they can be arranged crisscross. And if you had your super duper eyeballs on right now that you actually could see this, you actually could see the polymer chains, but we can't see the polymer chains, so we don't have the super duper eyeballs. So we're going to have to do a couple of things to it to try to figure out how the polymer chains are inside the Teflon or inside the plumber's tape. So what I'd like for you to do is that you have the tape like this, lengthwise on your desk. Everybody? Justin? Got it? Okay. Now, do you see the tape? You see the top part of the tape and you see the bottom part of the tape? Top and the bottom part of the tape? I want you to ever so gently stretch it out. Just ever so gently stretch it out. Don't stretch it out to the point where you're going to tear it, but go along your tape and ever so gently stretch it out from top to bottom. Okay, and other people in the classroom, if you want to take a look at what they're doing, make sure they're doing it right. See, kind of makes a cute little ribbon. Okay.
You made a cute little ribbon.
You didn't make a cute little ribbon?
No, mine stretched out. Then got a pinkly ribbon.
Okay.
It looks like yellow bacon.
Looks like yellow bacon. Okay. So that's something that I could do with this. Okay, can you guys see that? All right. Now, I stretched it this way. Did that tell me anything about how the chains were in the tape? Did you learn anything about how the chains were aligned in the tape? No, you didn't. Okay. Now what I want you to do is take one end and take the other end, and I want you ever so gently to stretch it that way. And tell me what happens. It goes back to normal. Okay? And if you want to have your other partners or somebody who didn't have a chance to do this again. It's stretching this way. And I'm kind of getting a real distorted. If I were to write my name on it and stretch it like this, my name would be real distorted. But if I were to pull like this, I would have my name nice and original again, or normal again. What does this tell you? Somebody here raise your hand and tell me what you think this tells you about how the polymer chains are arranged. Do you think the chains are arranged parallel to one another, or do you think they're crisscrossed based on what this could do? Do you think they're parallel to one another, or do you think that they are crisscrossed, depending upon what I could do with this? I see some hands going up, some hands going up. Jennifer, They're parallel, and why do you think they're parallel?
Because you can stretch it from side to side, and it's kind of easy to do it, and if it was crisscross, it would be harder.
Yeah, I agree with that. I don't know if you kind of heard what Jennifer said, but she said because of the fact that you could pull them side to side, and then you can get it to go back into its original shape again, just by pulling it this way. It's giving you an indication that the chains are parallel. If the chains were crisscrossed, do you think we'd be able to get it back to its original way real quick? No, we don't. Okay, so what I want you to do on your paper right now, you're bringing down plumber's tape. What I need you to do now is to tell me in your own words what evidence, or how did you know, in other words, that the chains, how were the chains arranged? And what evidence do you have that the chains were arranged in that certain way? In other words, if you think that the chains were arranged parallel, then tell me what evidence did you see that gives you an indication that the chains were arranged parallel? You really got yours stretched out, huh?
I got carried away.
You got carried away with it. So what do you think happened to your poor chains?
I ripped it.
Yeah,
You ripped it too.
I ripped it too. This brings up a point. Justin's poor plumber's tape. He really got it really stretched out.
But I explored my scientific thing.
Okay, you took it one step further. What do you think happened to these poor polymer chains from what Justin did to them? What do you think happened?
They got stretched too far and they ripped.
Yeah, stretched too far so they ripped. Very good.
Okay, whenever you stretch the tape out, do the chains get more compressed, or do they just get closer together? Or do they actually get more, like, do they all get thinner?
It will actually stretch out and get thinner. Well, I shouldn't, and then sometimes it all depends too. Okay? All right. Now, I'll give you about another minute to finish this up because the next part I have not been successful with all day long, and I hope I'm going to be successful with it today. I was semi-successful with it yesterday. John?
So if you got like your arm cut off or something, then all your polymer chains would be cut and everything?
Oh, absolutely. Absolutely.
Then how do you have polymer chains in your blood and DNA and everything?
Well, that's because you got to consider all a polymer is a gigantic molecule. It's smaller molecules put together. So all the molecules that you have, not all, but quite a few of them, are gigantic molecules, and all they are just smaller molecules that are hooked up together.
So whenever like you find a piece of DNA, that's not like your entire DNA strand?
No, it's not.
So
a little
is
piece.
your entire DNA strand like going up and down through your body all the way?
No. You got to remember, if you remember this from 7th grade science, if you were to take your cell and look inside of your nucleus, that big old gigantic molecule is really, really coiled inside the nucleus. Do you remember that? Okay? And yeah, and you can actually stretch that molecule out, and it's very, very long. But it's not all up and down your arm. It's compacted inside of every single cell inside of your body that has a nucleus.
How are the polymers arranged inside your body?
It all depends. All depends. Some could be arranged parallel, some could be arranged crisscross, some could be cross-linked together. All depends on what they're needed for, what they're used for. Okay? Any questions? Any other questions? Okay. This one I haven't been, like I said, I've been somewhat successful with it all day long, but I'm not 100% sure. This will be the last demo that I do, and then I'm going to break you up into your lab groups for you to investigate your own polymer. Does somebody in here know how to blow up a balloon really, really well and tie it off?
I do.
Justin. Do me a favor, when you blow the balloons up, don't blow them up all the way. And I think that's cool right there. That's good. Thank you. And Justin is dying over there, huh?
I like polymers.
Thank you. Okay. All right, we've got another problem. We have found another polymer, and we want to investigate again how the chains in this polymer are arranged. Okay, so we're going to do a couple of things to the balloon to figure it out. What I'm going to do is I'm going to take a skewer. I'm going to dip it in some oil just to be on the safe side to make it go in a little bit, how should I say, a little smoother. Okay, where should I put the skewer? Somebody in here tell me. I want to see whether or not I can figure out, like we did with the plumber's tape, we stretched it just different ways to see whether or not we can figure out how the chains are going. Same thing with the balloon. John, what do you think?
Poke it right on top.
Poke it on the top?
Yeah, right there.
Okay. Anybody want to go on the side? Scott wants to go on the side. Okay, Scott doesn't want to go on the side. All right. Scott, we're going to go on the side for you. Okay? We're going to go on the side. What do you think is going to happen? Why?
I think it'll go through.
You think it'll go through?
Yeah.
Okay, let's see what happens. Okay, ready? Oh, golly, that popped. Okay.
I do it right in the bottom, right where all the thick stuff is.
Right where all the thick stuff is, huh?
Yeah, it might not pop there.
Do you think that the thick stuff was not on the side?
No.
No?
Because it's stretched out more on the side and on the top. But down where the bottom is, it's not blown up all the way, so it's thicker on the bottom.
Okay, let's find out. Okay.
That's it. Yeah, right there.
Just to be on the safe side.
Oh, still popped.
And that's because I haven't been successful with this all day long. And everybody
Typing
has
is. Typing is.
Where's tied?
typing?
Yeah.
Okay. I don't like that one.
Yeah, get a new one.
Okay.
They must see that one's bad luck.
You sure, huh?
There we go. Not the other side.
Oh.
Here, I'll blow one up again.
Okay, blow one up. Give me two more, because I told you, sometimes this is working and sometimes it's not. But so far we got one part of it working, right? And don't blow them up really don't stretch them out too much.
I want the long one.
Here, try that one.
Oh, yes!
Okay, good. Thank you. Perfect. I'm going to be successful with this.
Yes. Use the force.
Use the force. Okay. All righty. Here I go. Should I try a different skewer? Okay.
Yeah, they're bad luck.
Okay. Here we go. I'm going to go from this end
Right where
first.
that big pot is.
Don't say that.
There we go. Bad.
Ah,
This is my balloon. It's
success.
my perfect balloon.
Okay, okay. All righty. What you need to do now is that when I put the skewer going in this way, it popped. But when I put the skewer in this way, it didn't pop. What's the difference between the chains here and the chains here? What's the difference? What's the difference? Cynthia? Oh, I don't know if it's parallel. What's the difference between the way the chains are arranged here? Not so much whether they're parallel or crisscross right now, but John had said this before. Justin?
The ones on the side are I guess so stretched apart that when you poke something in it, it just makes it pop because it won't stretch into where you could make something go inside.
Okay, and then what about the top?
And then the ones in top aren't as stretched apart and pulled so tightly, they're so loose, so you could just stick something in it and it won't pop right away.
Okay, excellent. So how do you think the polymer chains are arranged? Do you think they're parallel or do you think they're crisscrossed?
The ones on the top are parallel and the ones on the side are crisscrossed.
Okay, anybody else have anything other different? John?
I think that the ones on top may be crisscrossed because that means they're closer together, and then so you could stick something through and they squeeze around it easier and not have to explode. And the ones on bottom, but the ones on the side are stretched out a little more, so they're more like crisscross. So when you stick something, they just God, and they just explode.
Okay.
Bless you.
Okay, I like that explanation. And what John said was he felt that the polymer chains are crisscrossed. The ones at the top aren't crisscrossed, they're not stretched out. So when you poke something through it, the chains just kind of what was the word that you used?
Around it.
They kind of squeeze around it. Whereas the polymer chains, the crisscross polymer chains on the side are a little bit more stretched out. And so when you try to put a skewer through it, are you really getting, they can't squeeze together. I think that's the word that he used. The polymer chains can't squeeze together, okay? So we learned the balloon is what type of polymer? Parallel crisscrossed? Crisscrossed. And this is a little bit more compacted than this over here. So what can you tell me about polymers? Think about this. According to the balloon, what can polymers do? What can we do to them? Somebody's saying it. I can hear it. Yeah, they can stretch out. So polymers can stretch out. What I want you to do here now, same thing, same question. How are the chains arranged, and what evidence do you have that the chains are arranged that way? And if you guys want to draw a picture, you can go for it and draw a picture. That's not a problem. Okay. So, just out of curiosity, going back to that little original statement that we started out with today in class, the arrangement of the chains can kind of give me an idea of what's going to happen to the behavior of the polymer. And chains, crisscross, stretched out, and the balloon made the balloon pop. Chains compacted together at the top. I can put a skewer through it, and it's not going to pop. Okay, so the way the chains are arranged tells me something about the behavior of the material. Where is your? He's not here. Are you understanding this all okay? Okay. He hasn't been here for a while. No. Is he on vacation? Yes. Okay, it looks like pencils are down. All right, somebody now. Tell me something else I can write on this paper, what I just know about polymers. What did you learn about polymers today? What could you write down on there? Chris?
Polymers can expand.
Oh, yes, polymers can expand. Or you can use the word, we can stretch the polymers out. Anything else? That's bingo. Bingo, bingo. Okay. Nothing else? Nothing else. Okay, please go ahead and take this paper now, flip it over to the back, because now I'm going to let you investigate one on your own. Okay? All righty. And the one that I'm going to have investigate on your own is this one here. And I'm going to go ahead and turn the overhead back on. And you may want to copy this down, or you should copy this down on the back of your paper, so that there's not going to be any questions. You won't have any questions when you go into your lab, hopefully. Okay, investigating polymers. We investigated the balloon, and we investigated the plumber's tape. I'm going to have you go out and investigate the plastic container, or the polystyrene. And that's what you're going to investigate right there. Again, we have this question in our head. We have to figure out how these chains are arranged. You're going to do a couple of things to this plastic container to see whether or not you can figure out how the chains are arranged. And here's a monomer of polystyrene. can't, as you're writing this, I'm going to go ahead and share with you. You guys can get into your lab group, 3 to a lab group. You may choose who you'd like to work with. And after I go over the instructions, I'm going to tell you, okay, guys, you have a minute to find, or actually 30 seconds to find the partners in a lab station, okay? Okay, because I know you're all looking around at one another going, yeah. Okay? Okay. But let me have your eyeballs back up here because we've got to go through this. Okay, first thing. You're going to take your polystyrene container, your plastic container, and I'm going to show you what the plastic containers look like. Plastic containers look like this. Do you guys all recognize these plastic containers? Where do you see these? Look.
Oh, those are the cheesy hamburgers.
Yeah, the cheesy hamburgers are in there. Yeah. Okay, in the cafeteria. All right. What you're going to do is that you're going to take this plastic container and you're going to cut into a shape. And you guys can choose whether you want to cut it into a square, rectangle, or a triangle. The only reason why I'm asking you for those 3 particular shapes is because it's kind of easier to measure. I don't care how big you cut this out. I don't care how small you cut this out. That's your choice. What I would like for you to concentrate on in the container, though, is if there's a very, very flat part to the container. Do you guys see the flat part? Okay, so when you get into your lab groups, you just need to make sure that you're cutting off all this ripply edge stuff. Okay? And I'm not doing a very good job here. And cut the flat part out. Okay? From the flat part, then you can cut your triangle, you can cut your square, you can cut your rectangle, and you guys can cut it any size. Just remember, you have 2 flat sections here for 3 people. So you're going to have to figure out how you're going to divvy up 2 sections for 3 people. Okay? All right, so that's the first thing you're going to do. Second thing that you're going to do, and I had a piece here from this morning. I don't know what happened to it. You're going to trace the figure. So once you cut the figure out, I want you to trace it. And then I want you to take measurements. And I'm going to tell you how I want you to take these measurements. You have rulers in your containers back there at your lab station. What you need to do is that you need to measure the sides. Okay? I don't want to know length times width times height. I don't want to know that. All I want you to do is to tell me give me a measurement of the length, or actually of all the 4 sides. Or if you have a triangle, then you have 3 sides, okay? You're going to take these measurements in centimeters. Then you are going to go and you're going to give me a measurement of mass. Now, what is in the classroom that's going to help you figure out how the mass of this little piece of plastic? What's hanging around here? Daisy?
Triple beam balance.
The triple beam balance. So you're going to use the triple beam balance to help you figure out the mass. And how do you measure mass? In grams. Okay. And then give me some characteristics of the plastic. In other words, after you've cut your little shape out, tell me, what does it look like? Tell me something about the physical characteristics of that piece of plastic. What does it feel like? What does it smell like? Don't taste it. And you're going to do all of this 2 times. You're going to do this, watch, before you heat it, and then after you heat it. Whereas with the plumber's tape, we pulled it. As with the balloon, we skewered it. With this piece of plastic, we're going to put it in the toaster oven, and we're going to see what happens. So I've got the toaster oven up here. I'm going to man the toaster oven. So once it's been heated, you're going to take it back to your lab station, and you're going to do all this all over again. Question?
What if whenever we heat it, it like melts in and you can't touch it?
Oh, I don't know. We'll have to see. Okay? We'll have to see. You have to put all this information, the before and the after heating, into a data table. You guys remember what your data tables look like from before in the past, right? Okay, I'm not going to give you the data table today. I want you and your partners to figure out what your data table is going to look like. You just need to know that your data table has to have all of these elements inside of it, before and after heating, and you have to have all of this for all 3 of your lab partners on one data table. So what I mean is, if Savannah, Tegan, and myself were a team, we would all cut out our own different shapes. We'd all figure out our own different measurements, but we would share them with one another. So by the time I'm done, I have Savannah's, Tegan's, and my own all on the data table, before and after. Is that clear?
Yes.
Is that clear? Because there was some confusion about that this morning in class. So you're going to put everybody's data on here. You are going to trace everybody's figure on your paper. So when you create your data table, you need to keep that in mind. Okay, Chris? Question?
No.
Okay. All righty. No questions? And I think I've covered everything. Yep, I have. Okay. When you are done with your before heating measurements and you want to come up to the toaster oven, raise your hand, and then I will call you group by group to the toaster oven. I'm going to man it, and then you can take your plastic back to the lab. Okay? So when you're ready, just raise your hand, and I'll let you come up here, and we'll put it in the toaster oven. If you're done with the whole entire lab, you're done with the before, and you're done with the after, and you've done with all the measurements and everything else that you need to do, there are some conclusion questions that are on the board behind this board over here. And somewhere in the middle of the lab, I'll push that board over so that you actually can see those conclusion questions, okay? Ladies and gents, this is a lab today that you need to make sure that you are taking very careful measurements. What did I just say?
Very careful measurements.
Okay, very careful measurements, because I'm not going to tell you, but yeah, just go ahead and take very careful measurements, okay? Okay, 30 seconds. Find your partner in the lab station.
You type those?
Eyeballs. Let me double check and see who you're working with real quick. 3, 3, 3, 3, 3. You 3 ladies are together. Jana, who are you with? You 2. Okay, 3. It's you 3? Okay, you 3 and you 3. Okay, do me a favor. Maria, would you guys scoot down a little bit? Yeah, thank you. Keep scooting. That way we can get that group in totally over there. Scoot all, yeah, good. Adam, scoot down some more. Take your stool, take your stool and go right in the middle over there. Okay. Once I hand out your plastic containers, you guys can go ahead and start. Okay, gentlemen, there you go. Oh, yes. Yes, hurry up. Give me your binder reminder. I'll give you a pass. You 3 ladies are together? Is it just you and Clara?
Yeah.
Okay, guess what? There you go. And you 3 gents, you got some extra here, so use this and that. Yeah, good question, guys. If you need extra scissors or rulers, they're on my table next to my lab station. background music, it has to be Star Wars. You know what? There's some other pair of scissors on my lab table over there. Let me get you some cleaner containers.
Are we turning into a square?
Don't worry.
I'll get this movie side. That don't have it ready.
That's why I'm coming right
That's the
here.
good thing.
Trying this out.
That's really good. Why else do you think I like to I get the top and everything, and then you can say anything.
You know, you're talking about how you're going to organize this data table. Yeah. Yes. What do you need?
3 ways?
Yes, you do. Okay. So, if I were you, I would cut out whatever you have left over. You can get out. You can give to Lorenzo. Okay. Well, that's a good idea too.
It'll be a rectangle.
Would you guys just get one container? No, here, two. Okay.
Rectangle will be better.
Dustin, question? What do you need? They should be up here. Where are they? Oh, here they are.
I'll make a square. What are you making?
You guys can use that extra.
What are you making?
I must have put them away yesterday by accident. There you go.
A rectangle?
Rectangle. Here's extra if you want to make it small.
You guys can move it.
Okay, I got my ruler. How are we supposed to measure it? Like, are we supposed to just put all the measurements in one?
Massive, you mean? Yeah, you do.
I know centimeters, but I mean,
You put it on here to find the
like
max.
one side
Okay?
7,
But
the other side 7.
actually, it's pretty much clean. I cleaned them all yesterday, so you should be okay. But you want to double check and make sure it's aligned correctly. Okay?
But I don't think I'm going to have to.
And where is your shape? Okay. Now, if you guys need more rulers, you can go over my table and go get some. Yes, Lee. Absolutely. Okay, gentlemen, before you start, let me look at your data table. How did you pull that? How did you arrange that data table?
Oh, the one sheet of paper.
Yeah.
One sheet of paper, you have to have the data table. And who's doing it? Because I'm not.
All of you have to make a data table, remember?
Yeah, but it's supposed to be on one sheet of paper.
I thought it was his data table, my data table, and then his data. But we have both. There's 3 different data tables, but they all have the same.
Bingo, and you are correct. Okay, but you guys need to talk about how you're going to put that data table together before you do anything.
Oh,
Okay?
just make a square. Before and after.
Why not do a triangle? Triangle is cool.
I know that.
What do we gotta do square?
Okay, ladies.
Yeah.
Oh yes, you do have a data table. Let me take a look at that. Is this yours? How is this going to fit in there?
We have to trace it.
Yeah. So how is it going to fit in there? So maybe you need to expand them. If they're good, just make them a little bit bigger.
We need like
another piece of paper or
something.
Do I like fractions? No, I don't.
Anyone got paper?
Okay. And have you guys figured out how you're going to put your data table?
14/16.
Well, you know what? If I were you, I'd remeasure that and give me a decimal.
How do you do it with that?
Watch.
Oh, we get decimal?
Yeah. You guys know there's no fractions in here. So this is 7. Looks like it's about 7.2.
Oh yeah, we can do it in centimeters.
Yes, you have to do it in centimeters.
Okay, that's right.
So I'm concerned. You've got a before and you've got an after. But where is the room on the data table for his info and his info?
I'm going to do that later.
I'll try like now. Okay.
I just need a new piece of paper because
Go get another piece of paper if you need it.
I don't have enough paper. I'm just going to make a giant diagram.
Okay. And how is your data table coming along, ladies? Gentlemen, let me see your data table. Let's regroup here, okay? You have to get, is this your figure? Okay. You have to get all, well, let me see your piece of plastic. Your piece of plastic. Where's the other? Okay. You got to get all three of these somehow traced on your paper, because that needs to be included in your data table. Okay? Four. This one looks like it's chipped. And you're going to just give me a measurement here. This looks to be about 4.9. Yeah, maybe 4.9 centimeters. So when you trace it, you can put down on this side it's 4.9 centimeters. Okay? Yeah. And you know what? Sometimes an easier way is just to put all your data inside of it. Does that make sense? Okay.
Oops, I wrote Justin Ford. Sorry.
Yeah, okay. And how are you guys coming along here?
Good, we already got our data table.
You got your data table? Almost.
He stole my ruler.
Okay, so you got before and after, so share with me what's going to go in here.
The characterization.
The characteristics?
Yeah, before and then after you heat it
Okay.
up.
Now, do you have enough room to trace it? I'm going to give you a hint here. You can trace it, and you can put all of your data.
Information inside of it.
Bingo! Yes.
Tell me before.
Well, that's an easy way.
I can poke an eye.
So now I have to make my
you
data
can.
table
Be
out my
careful.
whole piece of paper.
Well, no, not necessarily. Just erase these little lines and just kind of extend the data table down longer.
What was I gonna ask?
What are you doing?
Okay, I was gonna ask something.
Good, I like it.
Tony, what was your side one?
Yes.
I think we're done.
Okay, let's double check. So you have to tell me, is this before heating or after heating?
Before.
Okay, so somehow you need to let me know that.
Okay.
Okay? And you ladies, how are you coming along? Okay, that's smart. And then you can put all your measurements on the inside. Okay? That's good.
Of each one?
Gentlemen, and what are you done? Are you done? You're massing? You're finding the mass? What are you doing?
The rectangle.
Okay, you're measuring. Scott, what are you doing? You can always get another one off of my desk.
It's crazy.
Justin, are we having a conversation about polymers?
The polymer of my
Alright, so I don't have to make a line.
You gotta get carpet in here because carpet cleans the erasers.
No carpet in the science room.
Yeah, how do we make the graph?
Oh, that kind of looks like it.
Make a graph, dude.
No, you're not going to give me a perimeter or an area. All you do is just give me the measurements. Okay? So you're not going to do any type of math calculation today. Awesome, huh?
Like, what if, like, you said something?
Yes. Are you guys ready to heat? If I were you, I would somehow block this off and put a title here before heating. Okay. Block this off and put a title here after heating. Okay, that way you can tell the difference. Okay? So, Daisy, you're almost done? Okay.
Now, where do we trace these?
So you trace it like on your thing, on your dad's table. You trace the bottom. Or
Yeah.
No, we have to do the math.
No, look, Tony, look at your writer. The very first, yeah.
I'm just making mine big.
They don't just want to make it even.
I'll do mine, you do yours. So if I mess up on mine.
Did I say anything about graphing? No. Yeah, the data table. And this looks to me like you've got one coming here, okay?
wait.
So you're all right.
In the middle of yours.
So do you have everybody's data?
Yeah.
Okay, you have all the masses? Okay, let me double check your masses here. Where am I going to find that on your data table?
Right here. Inside the little sheet.
Well, then you're going to need to identify that as being mass. Okay, that's fine. As long as I know what the mass is.
Their characteristics.
Are you guys ready to heat?
Yeah.
So, my suggestion to you is, am I looking at data here for before heating or after heating? Okay, so make sure I know that. How do I know that?
So make an after heating chart down here.
You can do that. So if I were you, I'd scratch that out so that I know that you're doing, yeah. That's fine. And maybe you wouldn't want to block the whole thing off so I know that that's all before heating. Okay, good. All right. Okay, I think you guys are ready. Are you guys ready too? Okay, bring your plastic on up. Okay, ladies and gents. Shh. Eyeballs. Eyeballs. Okay. If you're done with your measurements, your before heating measurements, you can raise your hand and then I will call you up here, okay? Once you're done, go back and do the after heating measurements. Once you're done with all the after heating stuff, then you are to absolutely record it. But say, for instance, everything's done with your lab. What are you going to do next? Sit in your seat and do the bingo. Okay, here we go. Ready? All right, so you guys need to cuddle around. Place your, ouch, it's hot. That's why I have the mitt. Yeah, put it up front so you guys can remember it. Daisy? Yeah. Put it all on the pan. Got it on the pan? All right, now you got to look through the window and see what's happening.
Is it like the shrinking?
I don't know. We'll find it. Oh. Yeah, hold on. Voila, voila, dot, dot.
Mine's still in the spot.
So there should be 5. Okay, here we go. All right, now crowd around and watch what happens. Justin.
Oh, a whole lot of them. Oh, never mind. There we go.
Oh, wow.
Ew, they're like folding.
They're like, and they're
Shrinking.
It's shrinking it.
And they're hardening as well. Look, that one's going into kind of like a cup form.
Ew. Okay.
What's so ew? Got it.
Let's see. Does it look like they're done?
No, they're still moving.
They're still moving? Okay. Yeah, yours are flattened out now. Okay, that's why I've got the oven mitt on, so I don't burn myself. These are hot, so you want to be very careful when you pick them up. Okay, very careful when you pick them up. There you go.
Not that hot.
It's hot.
Ah,
That one was mine. Oh, no,
there you go. They're hot?
No.
I didn't think they were that hot. Okay. Okay, team 10, team 9, if you guys are ready. Okay, place it on the pan.
Pan hot?
Anywhere on the pan. Yes, the pan's hot, so be careful.
Yeah, can we taste
Oh, I
this
know.
stuff?
No, you cannot taste it. John?
It smells like gingerbread.
I know, it's because it's close to lunch, too. Okay. Give me your plastics and put them on the pan.
Look at me. Were you baking in here earlier?
I was... Yeah, I make my little cinnamon rolls on here. Okay, here we go.
You make some mean green gum.
Now, you ladies need to come around here so you can see what's going on in the window. Okay, make some observations about what's going on with the plastic through the window. Okay, scoot in closer. It shouldn't explode.
Rolling up.
Oh, it's like it's turning into pieces of cheese. Oh, it's that. It's like that. It's like that commercial whenever they get small and hard, and then you can like fit them to your shirt and everything. I would fucking make it. I think. Look, it's like help me, I'm dying. Like
Are you ready?
Okay.
Oh my gosh.
So you think they're done? No?
Look down.
Until they get brown.
So what do you think's happened to those polymer chains?
They split up to stay cool.
Yeah, yeah.
Okay, they're getting done.
You think they're done? Okay, Amber, let me change places with you.
There you go.
Yeah, mine's like tiny.
Whoa, gosh, so small.
It's not on fire, is it?
Not on fire.
No, not like the other fire we had here the other day.
Oh, I know. I can't believe that. Is it
Not
hot?
my room.
So hot.
No. It's just cool.
Careful.
That one's yours. I got that one. No,
It's like glass.
It's like, because it feels different, huh?
Mine. Oh, I see mine. It is glass. It's all hot. It's like glass.
Okay. Is there anybody else that's ready to put it in the oven? Okay, team 5 and team 7. Okay, put them down on the pan. Careful, pan's hot. I'm going to scoot yours over just a tad so you guys want to remember where they're at. Gentlemen, over here. Pan is hot, so place them on there. Okay, now, I want you to look through the window and I want you to observe what's happening. So gents, you guys need to come over here. Come on, Darth. Over here, Darth Vader. Come on, Scott. Right here, look. Josh?
Oh my gosh, that's mine. Oh, it looks like a star. Oh my gosh, they're shrinking. Yeah, mine's like a flower. Look at mine, mine's dying.
So what do you think are happening to the chains? Yeah, they kind of pulling back together, huh? Or you think they're done?
Yeah, they're not moving anymore.
Not moving anymore?
Some of them are.
What do you think would happen if I left them in here for a long, long time?
They're really long. They'll probably disappear. Or they melt.
They might melt. Okay. trying to flatten them down. That way it'll be easier for you to take measurements because you need to notice that they definitely were curled up a pad. Okay? Oopsie. Come on over here. This one's real small. Okay. Alrighty, there you go, gents. And ladies, find yours. Are you guys ready? Are you ready? Okay, team 3 in the window. Okay, place them on the pan. Pan's hot, so be careful.
Okay.
Are you guys ready too? Okay, hold on one sec. Everybody's plastic is on there? Okay, watch what's happening through the window.
I'm gonna use it at what here?
Okay.
My side one was
Now it's like rough and it's not as smooth. I mean, it's still like see-through.
And it got dented.
Yeah. So it's like harder to trace and everything.
You guys need to go. You guys need to go, right? 2 and...
Did you guys even weigh yours?
I did. Mine's 1 gram.
What's happening to the polymer chain?
Because we cut ours out in different shapes.
Oh, mine's 0.9.
They're shrinking?
0.9. Is this 1? What's yours? What are you doing? It was fun.
No, it wasn't.
It was. It was right on the list.
Let me get in here again. They're tiny? Okay. This is why? No, don't grab. Yeah, you can take it. They're a little hot, so you want to be careful. Oh, Adam, they're not that hot.
That's so small.
And how much is your blade jacket? How much is your blade jacket?
I think that's it. All right, team 2 and team 8.
What's big?
Yeah, I'm so excited.
Okay, put this on the, oh gosh, you guys have big ones.
You probably picked them up from the garbage and started.
Ladies? Yes?
Yeah, look at mine.
No, hold on to
A
it.
very big thing. It's nothing.
Mine's cooler than yours.
All right, are you ready? What do you think, Christopher?
And this is yours, the little 7.
All righty, there you go. Look.
Is this a shrinking?
7. You guys look at it like it's
That's a toaster oven.
Let me see your pin. Why doesn't work? Nothing works on that.
Ladies and gents, I forgot. Ladies and gents, eyeballs for 1 quick second, please. I forgot to mention something to you. Shh. Please do not throw your little piece of plastic away in the trash can. When you're done, bring it back to your table, and I'll give you some tape. You're going to tape it on your paper, okay? Okay, how are you guys coming along?
Ours is small, small, big, small, big.
Mine's
Biggest.
like the smallest.
Mine's biggest in there.
Yeah, so what do you think happened?
Hey, mine went back up. Hey, my spin.
There you go. There you go.
Oh my god, it's so hot.
Be careful, they are hot.
That's hot too.
Don't even know what mine looks like.
No, go sit down, gents. All right. Is there anybody here that needs left to put them in the oven? It's just one more group? Okay, number 6, come on up. And other part of number 6. Last 4 ladies. Okay, put it in. Ooh, nice big ones.
Is it gonna go?
Jaina, you have yours? You need to come up here. 'Cause you need to see what's going on. Ready? And there we go.
No, but the little curvy parts when I got on the little bubble. Oh my god, it's reading!
John, question? No staple. Just have a seat.
There's like a bug. Well, it's all thick. This is all thick and good.
Oh, okay. Oh, do you think they're done?
Yes.
You think so? Okay.
It's like a bow.
I keep forgetting. I have mitt on the right hand.
Oh. Oh my gosh! Where'd he go?
Oh, in the water. Hold on. Not a problem. He just got it cold. That's all. Okay, there you go.
Can we take him away?
Yeah.
That's ours.
Take them away. They're yours.
Yeah.
What are you gents doing?
Hey, you can't see through it anymore.
I need to trace it, okay? I need to trace it.
Look, it's not even left leg.
I'm not going to tell anyone.
It's because this.
I'm being a good boy. Good. Act proper in the middle of class.
What are you supposed to be doing?
Or are you answering the question?
Yeah, correct.
You answer it right here on the back?
Questions. Yes.
Do we have like some classic rock bands in the background?
Daisy, if you hold on, I'll explain that when I get more of the class sitting down together. So we have a question about number 2? Yeah. Most of you do. And I'll tell you what I want you to do with that. But let me wait for let's go on to number 3 if you can. Ladies and gents, you have about 10 minutes left in the lab situation, making making measurements. About 10 minutes. Yeah, hold on. Are you gents done? Then my suggestion is to have a seat and work on your questions. Ladies, put the hat away. Let me check your masses here. Have you done masses yet?
Yeah.
Before and after mass? Yes, in the grams?
No, for the math.
Okay.
Oh, yeah. So it would still be 0.2. Give me your oh, Chris is square. You guys didn't give me any information about your stuff.
Well, are you done with your stuff?
Yeah, I'm done with mine.
Where's your little...
Did you take the mass of this yet? After?
Oh no, I didn't.
No.
Did on that one.
Ladies, let me check something here. Oh, excellent, excellent. Okay, good job.
Oh, so let's
No.
say and now it's needs to be showing hard like plastic.
Why didn't you come up there when I asked your group to come up there, Adam?
He does good shit, but
Now you're better.
tracing it. I need to trace it.
Dude, I gotta see the one thing too. Dude, it's like it weighs nothing.
Ladies, how are you coming along?
That's because this is
Okay, let me check your masses.
Dude, stop messing with me.
0.6 and okay, that's different. Let's see. Mass.
Which way do you go?
Excellent. 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 Very good job.
Well, one thing, this is up. Supposed to be on 0.
Keep going.
Watch what happens. Amanda, I'm going to pass around some tape, and what I want you to do is to tape that on your paper, okay? As soon as I get the rest of the class situated, I'll pass out the tape. Brad.
Let me trace your little kidney.
Where is it?
What are you doing, Brandon? Okay, then we need to answer number 2 and not talk to Clara.
Dude, your square doesn't even look like a square.
That's not his.
Mine.
You like got the wrong one.
No,
Has anything happened yet? Yeah, you're done. Good. It's hot, so you want to be careful. Okay? Okay, good.
Look how much you weighed it. Look.
John, no more.
See, it looks like it's a little less than black.
Absolutely.
I think I'm done.
Justin,
Okay, what's it weigh now? 2 grams.
what's yours weigh?
Oh, wait.
Get rid of the fractions.
2 grams after. 2 grams. How big is yours? What's Chris's?
3.4 grams.
Chris's is 3.4 grams.
2.2 grams.
How many centimeters?
3.4. I mean centimeters.
Okay.
And 2.
I need to do this on there.
Yes. Is this yours?
Yeah, that's mine and that's my family.
Okay. Okay, yes, you need to put that on your paper. I have a question for you. What? Before heating, you had 0.9 grams. After heating, you had 0.6 grams. What happened when you did some of the molecules go away? I mean, 0.6 is less than a 0.9. What happened to the molecules?
Yeah, come on, Justin.
Reduced.
They reduced? Where did they go?
They melted.
I don't know if they melted.
Disintegrated. It is.
Your characteristics before. This was thin, right? Wasn't this thin before? And flexible?
Yeah, now it's thick and it's not very flexible.
And it's not very flexible, but it's still thick. So do you still have those same amount of molecules in there?
Yes.
Yes. So what should these answers be?
The same.
Bingo!
Oh my gosh, nice.
Yes.
Dude, I got.
What is going on, gentlemen? Brandon, what's going on?
Nothing.
Clara, question? Okay. You never need to write the questions. You guys know that. That's right. If you're at your desk, you need to be working on the questions by yourself. Okay, I'm going to go ahead and pass around some tape. Make sure that you tape your little piece of plastic down to your paper. You knew that? Gentlemen, what were my instructions?
It's very brittle.
Yes, it is.
I broke it.
It's not as flexible as it was before, was it?
You could flexible it now.
Yeah, absolutely. That's good. Good, good, good. Justin? Not this Justin, that Justin. Wait for the tape. The tape is going up and down the aisles. All right, now that I have most of you here sitting down, let me go ahead and just kind of talk a little bit about the questions, because I know that there's probably a question here for number 2. So as soon as I have everybody's eyeballs up here. Okay. Question 1, it said, what happened to the polymer when it was heated? And what I want you to do is I want you to explain that. Okay, what happened to the polymers? Why do you think it happened? Explain what you saw inside the toaster oven. Number 2, your polymer should have had the same mass before and after heating. This is what we call a conservation of mass, because the root word is to conserve. Some of you in here, when I was walking around the room, a lot of you hit this right on target, man. You've got the same mass. Good job. Good job of measurement. Some of you in here, however, didn't get the same mass. And Justin, were you the one that I had the conversation with? Where did the molecules go anywhere? Did you still have the same amount of stuff that you had when you started? Yeah. So what did you just do to the mass? What did that mass look like at the beginning? What did your piece of plastic look like at the beginning before you put it in the oven?
And thinner.
It was maybe a lot bigger and thinner. What happened to you after you heated it?
It shrunk and got really thick and not as flexible.
Yeah, it just kind of shrunk, but it got thicker. So you just kind of changed the volume, but the mass is still there. Okay? Explain, and I kind of helped explain that just now, but I want you to explain why that should have had the same mass. And put that in your own words. Number 3, how do you think the polymer chains are arranged? Now we're going back to this thing that we started at the beginning of the class period, about the polymers and the polymer chains being arranged. How do you think they're arranged? And how do you think the arrangement of the chains influence the behavior of the plastic container? For example, prior to heating, your plastic looked one way. After heating, the plastic looked another way. What happened to the chains? Were they parallel? Were they crisscross? What happened to them? Tape is coming around too. Make sure that you tape your little piece of plastic on your paper. Justin, is this yours? Okay, good. You need to tape that on there with tape. Tape it on there. Not tape it around, tape it on. Scott, am I totally done? Good. Okay, good. Guys, don't worry about stapling your papers. You know I don't like papers stapled. Just make sure that your names are on both papers if you have more than one. When you're done, I want you to think about what you want to add to your cheat sheet over here. Clara? Okay. This is, how do you think the polymer chains are arranged? Well, you know that we talked about polymer chains being arranged two different ways. Remember that? Parallel and crisscrossed. Remember? Okay. How do the arrangement? So, how do you think that the chains are arranged in a plastic? Okay. Then, how do the arrangement of the chains influence the behavior of the plastic container? In other words, the chains were arranged in a certain way based on what you said. When you heated it, what did that do to the plastic container? I know. That's right. Tell me, how do you know that? What did you observe happening in the toaster oven? Yeah. Okay, guys. John, you have a question? Okay. Bell's going to be ringing in about 2 minutes. Let me share with you before the bell rings what I want you to do with these papers. If they're not done, finish them from homework. I see you again tomorrow. Very quickly, put them into the PIP section of your notebook. Go ahead and pack up, but don't be too loud because I have to tell you something at the end of the class period. Okay. Yes. No, I didn't. That happened with Escondido, huh? Buen Escondido? Yeah, no, I didn't see that. Guys, quickly and quietly. I have a couple of things I need to share with you about what's going to happen in class tomorrow. So while you're packing up, you guys can listen. I think I mentioned to you at the beginning of the class period today that when you come into class tomorrow, you're going to take a test. You're going to take a science assessment test tomorrow. This is a test that, I see the 2 boxes over there. The test is in the box. You guys remember like your Sat 9 test that you took last year? You remember you bubbled everything in? Okay, this isn't a bubbling type of test. This is a hands-on performance type of a test that you're going to be taking tomorrow. And it's going to take us the entire class period. So I really would like for you guys to come in, you know, having had something to eat in the morning, maybe at break, and come in. And you can, like I said, you can leave your science notebooks at home because you're not going to need them tomorrow, okay? Let's see, I told you about your assignment. Hold on to your polymer assignment until next Tuesday, because then what we'll do is that we'll kind of touch base a little bit about some of the things that you found out about polymers on Tuesday from these activities, and we're going to go ahead and we're going to add it to the piece of paper over there, okay? Okay, are there any questions? Questions? Okay. Let me double check. Let's see. Actually, yeah. No. 48. The bell should have rung by now. Or do we have one more minute? Oh. Okay, we have one more minute. Okay. All right. Well, then I'll ask you this. What can we add to this real quick? Well, does anybody in here want to raise your hand up and tell me what I could add to the piece of paper? What did you learn about polymers from this lab today? What did you learn that they can do? What did you learn? Derek?
They can change
How can they change?
from a parallel to a crisscross.
Well, they really can't change from a parallel to a crisscross. We'll talk about that. We'll talk about that next class period. Let's see, Savannah.
They could become smaller if you heat them.
When you heat them, what can we do to those long polymer chains? We can shrink them. Yeah. So polymer chains can expand, and polymer chains can. Yes, they do. Good. And we'll talk about that also next class period. Good. And what are you going to do with the balloon?
I'll blow it up in the class, let me tell you.
Because if you blow up the balloon and you get into trouble here at school, okay, you better promise.
And even if I do get in trouble, I'll say it won't.
Oh, yeah.
Say I found it on the ground.
Oh, yeah. Thanks.
I'm going to show it.
You too.
Yeah, you missed break detection. Yep, you had break detection.